All right, this is Mr. Sanders, and here are our notes for matrix multiplication. Specifically, we're trying to find out if the distribution property is true for matrices. Now we have three separate matrices, matrix A, matrix B, and matrix C. The question is, does A times B plus C equal A times B plus A times C? So let's take a look. Matrix A is 2, 1, negative 1, 3. B is negative 2, 0, 4, 2. And C is 1, 1, 3, 2. We're first going to try A times B plus C. And what we want to do is add the material that's inside the parentheses. So that's matrix A plus matrix C. Here, as we remember, the red goes with the red. They match up in position. So I've circled them in similar colors to help us remember that. Negative 2 plus 1 is negative 1. 0 plus 1 is 1. 4 plus 3 is 7. And 2 plus 2 is 4. So now what we have is matrix B plus C. Next step is to multiply B plus C times matrix A. Now down here what we have is the step-by-step multiplication. We take the first row of matrix A, which is 2, 1. We rotate it 90 degrees. Essentially what that means is taking the 2 and the 1 and matching it up with the B plus C column, the first column. That's the 2 with the negative 1 and the 1 with the 7. And then stepping over and matching it up, the 2 and the 1 with the 1 and the 4. So let's go through that. 2 times negative 1 is negative 2. 1 times 7 is 7. Negative 2 plus 7 is 5. We've stepped over to the next column in matrix B plus C. 2 times 1 and 1 times 4. We get 2 plus 4 and add those together and we get 6. Next we'll use the second row, negative 1 and 3 for matrix A, line it up this way and go through the process again of matching up with the first column in matrix B plus C and then with the second matrix column, B, 1 and 4. Negative 1 times negative 1 is 1, 3 times 7 is 21. Add those together, you get 22. Negative 1 times 1 is negative 1. Negative 1 times 1 is negative 1. 3 times 4 is 12. Add those together and we get 11. So now we have this matrix, which is A times B plus C, or 5, 6, 22, and 11. Now we're going to go ahead and see if doing it the other way gives us the same answer. The first step is to multiply A times B. Here's matrix A with the 2 and the 1, and then the negative 1 and the 3. Matrix B, negative 2 and 4, and 0 and 2. 2 times negative 2, 1 times 4, we get 0 as a sum, and that's going to go right here. Next is 2 times 0 and 1 times 2, we get 2 as a sum, and that goes here. Second row of column of matrix A. The second row of matrix A is here, negative 1 and 3. Negative 1 and 3 is the second row for matrix A. We put those here, rotated 90 degrees, and we match them up with the columns in matrix B. Negative 1 times negative 2 is positive 2. 3 times 4 is 12. Add those together and we get 14. Negative 1 and 3 again with 0 and 2. We get 0 and 6. Add those up and we get a 6. Now matrix A times B is 0, 2, 14, and 6. We next have to multiply matrix A times matrix C. Here's matrix A times matrix C. Take the 2 and the 1 and go with the 1 and the 3 for column 1 of matrix C. 2 times 1 is 2. 1 times 3 is 3. Add those together, we get a 5. Step over to column 2 in matrix C with row 1 of column A. 2 and 1 lined up, rotated 90 degrees. 2 times 1 is 2. 1 times 2 is 2. Get a sum of 4. The 5 goes here in row 1, column 1. The 4 goes here in row 1, column 2. Next, we'll take row 2 of matrix A, rotate it 90 degrees, and step through column 1 and then column 2 of matrix C. Negative 1 times 1 is negative 1. 3 times 3 is 9. Combining negative 1 and 9, and we get 8. Next column, negative 1 times 1 is negative 1. 3 times 2 is 6. Combining these, and we get 5. 5 and 4 were the results for A times C for row 1, and now we have 8 and 5, which are the results for row 2 of A times C. Now the next step is to add together A times B and A times C. Here's the results of multiplying A times B, 0, 2, 14, and 16. Matrix A times C was 5, 4, 8, and 5. Now adding them together, again remembering that the 0 goes with the 5, the 2 goes with the 4, 14 goes with the 8, and the 6 goes with the 5 because this is addition. The result is 5, 6, 22, and 11. Those are exactly the same results as when we had done it the other way, when we had added together matrix B plus matrix C and then multiplied by matrix A. The results are the same as multiplying matrix A and B and then multiplying matrix A and C and combining the results. That's really great because that helps us with our next steps. We do need to remember that it's not necessarily true that A times B would always equal B times A. That works in algebra, but in matrix multiplication, it does not work. All of this is the preliminary step to leading us to discuss inverses of matrices. To do that, let's think about some of the concepts we already understand about mathematics and algebra. First of all, if we say 4 divided by 2, that's really the same as 4 times the reciprocal of 2, which is 1 over 2. This is important because division does not work in matrix math. So 2 is the same as 2 over 1, and the reciprocal of 2 over 1 is 1 over 2. Another thing we need to think about is the fact that exponents with negatives preceding them signify moving a number, moving the base to the opposite position in the fraction bar. So essentially 2 to the negative 1 is going to be the same as 1 over 2. The negative sign means move the number to the different position. If it's in the numerator, it goes into the denominator. If it's in the denominator, it'll move to the numerator. Keeps the exponent, removes the negative sign, and we have 1 over 2 to the negative 1 is really the same as 2 to the first power. We want to take this idea and apply it to matrices. Matrix A divided by matrix B can't do it. It just won't work. But as we already discussed, the idea is that matrix A times the reciprocal of matrix B, or really what we'll call now the inverse of matrix B, that does work. This is multiplication. We already know that multiplication works for matrices, so we can express this concept of dividing or multiplying by a reciprocal in this form, A times the inverse of matrix B. The next step is to figure out how to calculate the inverse of a matrix. And we'll cover the beginnings of that in our next class.